Have you ever wondered how a jet engine works? These metal beasts roaring with power are the lifeline of modern transportation, propelling us across continents and oceans. From the smallest private planes to the largest commercial airliners, jet engines keep them all soaring in the skies. But what makes them tick? What's happening inside those enormous cylinders that allows us to break the bonds of gravity and take flight? Buckle up, folks, as we delve into the fascinating world of jet engines. In the next few minutes, you will learn the basics of how a jet engine works. First, it's important to know that there are different types of jet engines. We have the turbojet, the granddaddy of them all, known for its simplicity and speed. Then there's the turboprop, a workhorse that shines in efficiency at slower speeds, often seen in smaller aircraft. Finally, we have the turbofan, the most common type in commercial aviation, a hybrid of sorts, offering a balance between speed and efficiency. Now that we know the different types, let's delve into how one of these engines works. To understand how a jet engine works, you need to know its main parts. Let's start with the intake, also known as the inlet. This is where our journey begins, as the engine sucks in air. Next up is the compressor, which is like a multi-stage fan. It compresses the incoming air, increasing its pressure and getting it ready for the combustion chamber. Now the combustion chamber is where the magic happens. This is where the compressed air meets the fuel. They mix, ignite, and create a powerful explosion. This explosion generates a massive amount of energy, which powers the next part of our engine, the turbine. The turbine is essentially a windmill inside the engine. It's driven by the high-pressure gas from the combustion chamber, and its rotation powers the compressor. Finally, we have the exhaust. This is where the hot gas gets ejected, creating the thrust that propels the aircraft forward. With these parts in mind, we can now explore the process of how a jet engine works. So, how does a jet engine work? Let's dive right into it, shall we? First off, air is drawn into the engine. This is facilitated by the large fan at the front of the engine, which pulls in a great volume of air. It's like a giant vacuum cleaner, except it's not interested in dust bunnies. It's all about the air. Next comes the compression stage. The air is funneled into a compressor, which is made up of several stages of spinning blades. As the blades spin, they squeeze the air, making it smaller and smaller. Think of it like squeezing a balloon, except instead of popping, the air becomes denser and hotter. Once the air is compressed, it's mixed with fuel in the combustion chamber. This is where things really start to heat up. The fuel-air mixture is ignited, creating a high-pressure and high-temperature gas. It's akin to lighting a match in a closed box. The resultant force is immense. This powerful gas is then directed towards the turbine, causing it to spin rapidly. The turbine, in turn, powers the compressor and fan at the front of the engine. It's a neat little cycle, isn't it? Finally, the leftover gas, still hot and under pressure, is ejected out of the back of the engine. This ejection causes a force in the opposite direction, a reaction, you might say. This reaction is the thrust that propels the aircraft forward. It's Newton's third law in action. For every action, there's an equal and opposite reaction. And there you have it. That's the jet engine process broken down into simple steps. Air is drawn in, compressed, mixed with fuel and ignited, and then expelled to create thrust. It's a complex dance of physics and engineering, of pressure and temperature, of action and reaction. That is the basic process of how a jet engine works. But what are the advantages and disadvantages of this technology? Like any technology, jet engines have their pros and cons. On the bright side, jet engines are powerhouses. They're capable of propelling massive aircrafts at high speeds, making long-distance travel a matter of hours rather than days. They're also remarkably efficient, converting fuel to thrust with minimal energy loss. However, they're not without their drawbacks. Jet engines are notoriously noisy. The roar of a jet engine can be heard for miles, posing issues for those living near airports. And let's not forget their environmental impact. The burning of jet fuel releases carbon dioxide into the atmosphere, contributing to global warming. Moreover, jet engines are complex and expensive to maintain. A single malfunction could lead to catastrophic consequences, hence the need for meticulous maintenance and regular checks. So next time you see a jet plane in the sky, you'll know a bit more about the powerful engines that make its flight possible.